Okay, let's get started with 3-3 graphing techniques using transformations. So, all right, what are we going to do here? We're going to take the basic graphs that we learned last time, like x squared, which is the greatest parabola in the world, kind of stretches at the top, x squared, or x cubed, if you remember, x cubed should look like that, or the square root of x, which looks like that, starting from a point there at the origin, or even absolute value of x, which if you remember correctly should look like a nice B. And we're going to move them up, down, left, right, and stretch them, all sorts of good things. We're going to transform them in different directions and in different shapes. So here is our cheat sheet. These are the things you want to remember. Okay, to summarize this, if the change is with the x, then it's horizontal. Right? Because if we draw a coordinate plane, the x-axis is horizontal. So anything dealing with an x, like here, or down here, we see a negative in with the x, that's going to be horizontal. Okay? If it's with the y, then you can probably see that it's going to be vertical. So, for instance, like this one, the f of x is your x is in here. This c is not with the x, so it's with the y. So it's going to be a vertical shift. Okay? So we'll talk about this a bunch as we go through, but if it's with the x horizontal, if it's not, it's going to be vertical. Now, the other thing you need here is that if it's with the x, opposite sign. Okay? So on this one, in the x-axis, the plus is over in this direction. Sorry, it's very messy at the top of the screen. It doesn't pick it up correctly. Sorry about that. There we go, minus in this direction. All right, if we say minus with the x, that actually means you're going to go in the plus direction. So with the x, opposite sign. Okay, to graph everything, we need to know some key points of our graph. So x squared, if you remember, looks like this, going through the origin. The key points that you always need to know if you do a t-table, but we're going to start with the origin. The origin is 0, 0. I would like you to know 2 points on either side. So a good point to the right would be if x is 1. What's 1 squared? 1. And then the next important point, let's try 2. What's 2 squared? 4. Now this is symmetric, so if you plug in -1 squared is 1, and -2 squared is 4 with a positive, because negative squared is a positive, right? So over here we would have -2 comma 4. Over here we'd have 2 comma 4. All right, for x cubed, if you remember, x cubed should look like this going through the origin. Again, I want you to know the origin, and I want you to know the 2 points on either side. So -2 to +2. 0 cubed is 0, 1 cubed is 1, -1 cubed is -1. And then 2 cubes are 8, positive and negative. All right, and then square root. For the square root, it looks like this. Since it only goes in one direction, I only need you to know 3 important points for square root. So the square root of 0 is 0, the square root of 1 is 1, and the square root of 4 is 2. So know those 3 points. And then absolute value looks like this. It's a v. So again, you should know that the origin, the absolute value of 0 is 0, the absolute value of 1 is 1, the absolute value of 2 is 2, and for the negatives, the absolute value of -1 is 1, and -2 is +2. So make sure you have those important points down. We're going to use these to shift things around. All right, so sketch the graphs of the given functions using horizontal and vertical shifts. So let's look at this first one. X squared is our regular graph without any shifts. That's called the parent function. Parent, like your adult, right? So the parent function, normally x squared looks like this. And the -1, is that -1 with the x? No. With the x would be something like x - 1 squared, right? Inside the parentheses. Yeah. This is not, so it must be with the y. So we're going to be vertical, up or down, right? And the minus means let's go down by 1. So this graph is going to be shifted down 1 unit. So instead of starting at the origin at 0, 0, we're going to be down 1 unit like that. All right, so we always need to get those 5 important points for x squared. You can either label them on the graph, or put them in your t-table. I prefer doing the t-table. So now we know that 0, if x is 0, it's no longer 0, it's down 1. Now it's -1. Okay? Let's plug in 1, right? So 1 should be, 1 squared is 1, but it's going to be shifted down 1. It's going to be at 0. So right there. And if you're not sure about this, you can always plug it in. What's 1 squared? 1 minus 1 is 0. This is symmetric, so -1 will also be 0. And then 2. 2 should be at 4. It's shifted down 1, so it's going to be at, I can't fit it in there. 2 is going to be at 3, and -2 is also going to be at 3. If we're not sure, we can plug it in. 2 squared is 4, minus 1 is 3. All right, what about this one? This is a +1 in with the x. So remember, normally we would be here. This is going to be shifted. Remember, x, we're going to go opposite. So instead of the +1 direction, we're going to go in the -1 direction. So your new origin is going to be right here. Let's label those 5 important points. So we're going to go -2, -1, 0, 1, and 2. So 0 instead of 0, right? So 0 plus 1 squared, that's 1. -1 plus 1 is 0. 0 squared is 0. -2 plus 1 is -1 squared is 1. Right? So you can see the symmetry shifted over here. And then 1 plus 1 is 2, squared is 4. And 2 plus 1 is 3, squared is 9. All right, your turn. Give it a shot. So x squared plus 1, that's going to be shifted up 1. I'm going to start right there and shift it up. What are our 5 important points? So we'll go -2, -1, 0, 1, and 2. Whoa, come back. Sorry about that. Computer is freaking out. So 0 turns into 1, 1 and -1 turn into 2, and 2 and -2 turn into 5. All right, how about this one? X minus 1 squared. This is going to be shifted over to the right by 1. Shift up like that. And we'll have a t-table. Now on this one, if you were really fancy with this one, what you could do is give me 5 really good points where the center now is next value of 1. So going like this would give you 2 points on either side. So 1 minus 1 squared is 0, and then 0 minus 1 and 2 minus 1 are both 1, and then 3 minus 1 is 2, squared is 4, and this will also be 4 with your symmetry. Okay, let's do the same thing here. Your square root graph, this is going to be shifted left by 1. So instead of here, it's going to be left like that. And so our 3 important points for this one. So we're going to start at -1. -1 plus 1 is 0. The square root of that is 0. Then we're going to plug in 0. 0 plus 1 is 1. The square root of 1 is 1. And then we're going to plug in 3, because 3 plus 1 is 4, and the square root of 4 is 2. Those are our important points. Okay, this also says, tell me the domain and range. So the domain starts at -1 and goes to the right forever. So the domain is x is greater than or equal to -1. The range, the lowest y point is 0, and it goes up forever. So we say y is greater than or equal to 0. All right, for this next one, we're going to take our square root graph and shift down by 2. We'll go down 2, and it'll take off like that. And so our t-table, the x's didn't move, so the x's are still 0, 1, and 4. And so for this one, the square root of 0 is 0, minus 2 is -2. The square root of 1 is 1, minus 2 is -1. Square root of 4 is 2, minus 2 is 0. Domain, x is greater than or equal to 0. Range, y is greater than or equal to -2. Your turn. Square root -2, it's with the x, we'll go the opposite. That's right here. Takes off like that. So for our t-table, we'll start with 2. 1 more is 3, and then from here we go 4 more is 6. So 2 minus 2 is 0. Square root of 0 is 0. 3 minus 2 is 1. Square root of 1 is 1. 6 minus 2 is 4. The square root of 4 is 2. domain is greater than or equal to 2. Range y is greater than or equal to 0. All right, absolute value of x. Normal absolute value would look like that. So this is going to be shifted up by 1. So our 5 x values would be -2. Come back. There you go. -1, 0, 1, and 2. And so the square root of 0 is 0, plus 1 is 1. Square root of -1 is 1, plus 1 is 2, 3, and 2, and 3. Domain is going to be all real numbers. It goes left and right forever. Range, y is greater than or equal to 1. Okay, so we've got horizontal and vertical shifts on this one to put them all together. So here we've got a shift left 1 and down 2. All right, so this says sketch. When it says sketch, you don't need to plot the points. You just need to have the general shape. So left 1, down 2. So this is going to be the center of our x squared graph. X squareds look like this. So it's going to be something like that. Domain goes left and right forever, so all real. Range, y is greater than or equal to -2. Your turn. Okay, so this is right 2 and up 1. So we're going to go right 2. We're going to go up 1. That's the start of our absolute value sketch. Domain goes left and right forever, all real. Range, y is greater than or equal to 1. Okay. All right, so we've got reflections now on this one. So this says flip it over. So we're going to flip it over. Is that negative in with the x? No. So we're going to take our normal square root and flip it over vertically like that. And we are going to shift this to the right, to the left by 1. So we're going to, instead of starting here, we're going to shift here, and it'll be flipped over. That's your sketch. Again, sketch means you don't have to plot the points, just need to have the general movement. All right, so another sketch here. How about that? All right, so this is going to be up 1. This says, so that's a +2. Another way to write this would be -x plus 2. So the 2 there, we're going to go opposite because it's an x. So it's going to be left 2. And then we're going to flip it over horizontally. So we're going to have a horizontal flip. Another way to say that is flexion instead. Okay. All right, so on this one, if you want to think about this, it's hard to think about, do we go left first and then horizontally flip it? Or do we flip it first and then go to the left? So the answer to this is, what's the domain? The domain minus x. The biggest thing x could be would be 2, because 2 minus 2 is 0. You can square root 0, but you can't square root a negative. So if x was 3, you couldn't square root negative and have real numbers. So 2 is the farthest you can go. If x is 2, you'll have your point right there. The square root of 0 is 0 plus 1. So it's key. The key here is that what we really did is we went up 1, left 2, and then we flipped it over. So we ended up over here. Right? So we're going to look like that. For these tough ones, until you get good at it, plug it into Desmos and see what it looks like, or plug it into your graphing calculator. All right, so give it a shot. See if you can use shifts and reflections to sketch this, and then tell me the domain and the range. All right, so this is a vertical reflection. Because of this is going to go right 1. This is going to go 2 because of this one. So again, on this one, 1 is going to be your important x number, because 1 minus 1 is 0. So what happens if you plug in an x of 1? The square root of 0 is 0. Then plus 2 means you're going to go up like this, right? And so here we're going to go upside down because of the reflection. Domain x is greater than or equal to 1. Range, y is less than or equal to 2. All right, so that'll do it. We'll do some more examples in class, and you're going to play with Desmos a little bit to get these, but that will do it for now.